And we're live.
All right.
Hey.
Yeah. Hello, everyone. Welcome to the monthly audio programmer virtual meetup. My name is Timur. I'll be your host tonight together with Josh Hodge. Hello, Josh.
Hey, how's it going?
And we have two wonderful guests today as well. Really excited to be here. Thank you so much for tuning in. Before we get to our guests, we have a couple announcements and a couple kind of things to share. One of them is obviously last month, the Audio Developer Conference took place. So really happy with how that went. Thank you all so much for everyone who has participated either as a speaker or as an attendee or as a volunteer. We had a great time. It was awesome. Thank you so much. And I think Josh wants to talk about ADC a little bit more as well.
Yeah, absolutely. And once again, like Timur said, we'd like to thank everybody who participated in the ADC. So we had a lot of people who submitted talks. We had volunteers from the community who also gave their time selflessly. And thank you also to all the people who actually attended the conference as well. And it was a really successful conference. We got a lot of positive feedback. Of course, we always want these events to be welcoming and inclusive as possible as well. And I think that we made a lot of positive movement forward on that. And so thank you to everybody who came out to ADC. The videos are, most of them, I think nearly all of them are now on the Juice YouTube page. So you can actually go view them for free. It's on if you go to YouTube and you search Juice, it's on their YouTube page, and they have I think nearly all of the videos there now. So you can view them, and a lot of really amazing information. Speaking of Juice, we wanted to thank them for being a sponsor of the Audio Programmer Meetup, along with Sonics and Focusrite. So thank you to our sponsors for making this meetup possible and for helping us to do this every month. Also, wanted to let you know that we encourage people to continue these discussions in our audio programmer community. You can join the audio programmer community on Discord by going to theaudioprogrammer.com/community. And we also have a number of roles that are out there from some of our clients. So some of our clients approach us and ask us to help them recruit for roles. And we have a number of C++ roles and DSP roles as well. And you can actually find that on theaudioprogrammer.com as well. So if you're looking for a new opportunity, come talk to us. So I think we're ready to get our first talk started. So what do we have coming up, Timur?
We have something really interesting coming up. Let me just say one more thing before we do that. So this is actually the last meetup of the year. I really hope that we're going to have more awesome content next year. And so for that to happen, I really encourage all of you to actually come here, be part of the show, give a talk or do a Q&A with us, participate, no matter whether you're a student and you started or whether you're a seasoned industry expert. I really encourage you all to go to theaudioprogrammer.com/submit and submit your idea for a talk or a presentation here at this meetup, and to come and join us here in the new year. So really excited for new content there.
Yeah.
And with that being said, let me introduce our first speaker of tonight, or morning or day, depending on what it is in your time zone, who is, we have with us Chris Moan. Hello, Chris.
Hello. Good evening.
So Chris works at NVIDIA as a programmer from NVIDIA, but actually tonight is not representing NVIDIA, but instead is here to talk about a personal project that he's been working on for a while. And so I'm really excited to hear more about that. Chris, over to you. Oh, and sorry, one more thing. If you have questions for Chris or any other speaker here, actually, please feel free to ask your questions on the YouTube chat thingy. And please do us a favor. And if you ask a question, please prefix it with question in capitals, so it's easier for us to spot that in the stream of comments, and so that we can pick out your question and ask it at the end of the talk. All right, with that, thanks, and over to Chris.
Good evening. Let me share my screen.
Hi, my name's Chris Moan. I work at NVIDIA doing graphics, but today I'm here to talk about a personal project that I've been working on for a few years now. It's a live coding IDE. So who am I? I started my career at 3D Labs. I read the OpenGL manual on the train on the way to the interview and luckily got the job and ended up spending 5 years writing DirectX device drivers and working on GPU architecture. After that, I ended up at NVIDIA for about 23 years now and counting. I do tools for developers, all sorts of things, plugins. Particularly over the last few years, I've worked on the Nsight tools, GPU Trace. I think I've got a screenshot of that here. You can see this is GPU Trace on the top left, which is a tool that's looking at the GPU and figuring out what's going on inside a frame. There's also a screenshot of Nsight here, which is showing, I think, some of the ray tracing stuff that's gone in recently, which I didn't work on. But the trace tool at the top here, the scrubber here, and the traces of the graphics chip in the GPU Trace application are things that I've tended to specialize in at NVIDIA. The tools at the bottom, FX Composer, is a shader editing tool which I worked on for a few years early on, and then an even earlier example there of shading. I do like to do other things. Over the last few years I've done many experiments. I've done a couple of simple games, played around with various visual things. I like to do visual programming. I like things that draw pretty pictures on the screen. There's my website there if you want to look. These are just images from that. So what is live coding? It has many definitions. One of the examples here is an algo rave where you've got people sat in front of laptops composing music and graphics. Presumably there's an audience there as well dancing to the music. It can be done in many different ways. It's quite typical, as you can see here, to have one programmer doing the graphics and one programmer doing the sound. I've put a couple of links there. There's a really nice article in the FT about what Algorave is, and the Awesome Creative Coding website has hundreds of links for all sorts of interesting tools. So I'm just going to highlight a few that are kind of important to me, that have influenced me. I'm going to talk about Sonic Pi, which is a music composition tool written with a Ruby DSL, and I'm going to talk about Tidal Cycles, which is based on Haskell. I'm not going to show Tidal Cycles actually because I'm having trouble running it on my machine, which isn't uncommon. It's quite picky to install sometimes. I do have it running on my MacBook, but not on this machine. I'm going to show Shader Toy. I'm going to show Super Collider, which is often the foundation of some of these tools because it's the back-end synth that is generating the sound. And I'm going to show Jibber, which is a JavaScript audiovisual web application. So I'll just show you a little bit of each of these. So this tool is Super Collider, probably familiar to many. It uses a built-in language called sclang, which you can use to generate quite complicated synthesizers. I've got a simple example here. I can hit Control Enter. We'll hear that there's two sine waves being played at different frequencies, 456 and 442. I've got a more interesting example here off the SDK. We'll try this one. You can see that that's well, you can hear that one's a much more interesting sound, and you can look at the code and it's quite obvious what it's doing. It's generating some envelopes, it's doing some low-pass filtering, a white noise here to generate this snare drum. So a powerful system. This is the Windows build. It's a little bit difficult to use. The windows are very tiny on my display. It didn't work for about a year on Windows. It seems to be quite Linux centric, at least from the UI's point of view. But it works. The editor is sufficient. It has pop-up tooltips and things like that, so it does help you write the code. But it's a very, as you can see, very minimal user interface. This application is Sonic Pi, a very popular live coding tool for music. It was created by a guy called Sam Aaron, and I really recommend you go over to his channel and listen to some of his music created with it. He has a very professional setup which enables him to do this great AV performance that he does all over the world. There's an example here, a more simple piece of code. If I run it, you can see it plays the music, and it's generating the music at the back end using Super Collider actually, which is being used as a server to supply the synthesizer facilities. So that's Sonic Pi. This is a live coding environment for pixel shaders for graphics. Let's have a look at this one here. You get the shader code here and the visual effect there. I can actually spin it with a mouse. Very pretty. Let's have a look at it full screen. So this shader works by generating rays which are fired into the scene and stepping along the rays to try and figure out what the rays hit and what the color of each pixel should be. The shader's here, so you can read through it and tweak the visual effect, see what happens by changing things. Let's make that a 9, see what that does. It moves the sphere further away because we changed the camera. The last one I want to show is Jibber. This one is a JavaScript live coding environment that runs inside a web browser. As you can see, this program is generating some music. There's a drum pattern here, a synthesizer, and then it's doing an FFT of the audio in order to convert it into frequency bins, and then drawing the color bars. So it's a tool that you can use to make music and visuals. It's very nicely done, very easy to use, and very accessible because it's right inside the browser. It's a nice tool. So if you look at all those tools, what's interesting about them, they often have very basic editing. They're not built as powerful IDEs usually. Usually the editor is just the thing that they need to get to the next thing, and it's not something that's been, not all the time, been really thought about. So there are some exceptions. The Sonic Pi editor is pretty good. Pops up tooltips, helps you with the code as you write it. But in general, a lot of these tools you see have very basic editing facilities. There isn't usually any connection at all between the code you write and the music you hear. And what I mean by that is it's really difficult to see, why is that visual happening now, and how does it relate to the sound I'm hearing, and how does the sound I'm hearing relate to the code I wrote? Which note is being played from the code where I declared it, if you see what I mean. So that's an interesting aspect of live coding, and something that I want to do more research into. If you go to one of these algo raves, there's these, what I've called here, transient moments of greatness, where you might hear 10 minutes of confusion while the programmer is trying to figure out why their program isn't sounding nice, or they're experimenting with various pieces, and they kind of haven't quite hit the groove yet. The music isn't there. That doesn't always happen, but it can happen. But there are often these moments of greatness where everything comes together, and there'll be a minute or two of great music and great visuals. And I always think it's a shame that goes away, because the next stroke of the keyboard, the shader has changed, the music has changed, and you've lost that that serendipity of discovery that often occurs. So I've been thinking a lot about that. I would love to make my tool capture snapshots of where it's at and allow people to play back a performance. And I think that's somewhere I really want to get to eventually. As I said, some of the tools are complex to install. I couldn't get Super Collider to run on this machine for about a year. I can't get tidal cycles to run at all. Sonic Pi did install, although I had to remove a virtual drive, which took me an hour or two to figure out. And I actually helped them improve that software at some point in the last year or two to make it easier to install. And they don't usually have error reporting debugging. There isn't really an easy way to see, why is the machine suddenly dying? What's wrong? Where is the, have I created too much music? Have I created too much? Is the visual too expensive? What's wrong with my shader? Is it really reporting the right line in the shader where I wrote the code incorrectly? That's something that happens quite a lot, and it can be very frustrating. And as I said, what's my performance? I might want to be sure that when I give this performance on my laptop in a club, it's going to run, it's going to be fine, and it's not going to glitch. So this is the tool I've come up with. This is where I'm at so far. It's called Resonality. It's an IDE for audio and visual. It's kind of a toolbox, really. There is a layout mechanism, so you can be in this mode. You could be using it just to research shader development, but there's also a mode where you can swap the layout and it becomes more like a live coding environment where all the UI gets out of the way and you just see the shader code overlaid over the visuals. That's not something I'm going to demo today because it's currently a little broken, but I'll get that fixed eventually. But yeah, so it's what you make it. You can configure it for how you want to use it. So I'm going to give a brief demo of where Resonality is at the moment. Obviously I'll show more specific parts of it later, but just to give you a general feel for how the tool fits together. Let's start in the editor here. We'll make a synthesizer. This is the output graph, which is the synthesizer that sits at the back end and does the mastering and a bit of audio analysis. It's needed in all graphs. Let's create something really simple. This is an oscillator. You can see it was created here. I can play with the UI. Let's go and make something more interesting down here. I've got an analog synth set up. I've got another synthesizer down here. Let's try that one. You see they're all playing nicely. The 3D renderer here is sampling the audio information. We haven't got anything on the timeline line yet, but we haven't scheduled any notes. We'll do that in a minute. Okay, so let's make some music using the ICSI language, just something simple. We can make a drum pattern here. Let's just stick with that. We can fire that off. Oh, I need to initialize all the synthesizers. Let's do that. Okay, so we've got that. Let's go back into the music and try again. We'll make the drum sound. You can see in the timeline now we've got some patterns appearing, and you can see the visuals reacting to the music. The pixel shader in the background. Let's try some claps. And we can go in here and start playing, adding more synthesizer sounds. Let's just make a simple pattern there. And let's make something more interesting with the mandolin. Let's say we do something like this. Let's make this follow it a little bit somewhere. We'll just briefly turn off the music so you can hear me speak. So as you can see, the timeline here, those patterns are being generated and scheduled. We had the visuals jumping around to the music. The synthesizers, the orange lights here indicate which synthesizers are active and running at the current time. There's a debug here which is also telling me kind of how many notes are in each synth. I'm going to show you next how to change the output of the visuals. So there I went in and changed the vertex shader, which is describing the shape there, and I've changed the background to a different shader. And the final thing I just wanted to show briefly is the profiler, which has been running away in the background here. This thing can, let's actually run it again with some audio so you get a more interesting pattern. We'll start it again. And you can see here, I actually have a profiler that can look at the audio thread or the graphics thread. So the line along the top is what's going on in the graphics, the line along the bottom is what's going on in the audio, and then I can analyze what's happening in the threads in the engine, what's happening in the UI and the graphics here. And that's it for an introductory demo. I'll cover some more parts of it later on. Yeah, so the basic technology in the tool, it's C++ 17. It would be 20 if I could get away with it. I like to use the latest tools. Why shouldn't I on a project that's a pet project of mine? It means I can learn new things. I'm using the Janet scripting language, which looks a little bit like Lisp, but has some mutable pieces to it, I think. It's a very nice language to embed, very easy to use. I've been really pleasantly surprised by it. I used to use a built-in scheme, Chippy scheme, I think it was. But I've found Janet much more user-friendly in many different ways. It uses IMGUI. Most game developers use IMGUI for their overlays, for their toolkits when they're building games. It's a hugely popular toolkit. I've only just noticed that appears to be mirrored on the slides, which is interesting. And yeah, the graphics library at the moment, I'm using OpenGL, just because OpenGL runs everywhere. It's not really recommended on Mac anymore, but it does just run. I also have built a DirectX 12 version of it that kind of works but needs some TLC, and I even started a Vulkan version because I am interested in the graphics aspect as well as the sound, and I'm really looking forward to building those out. So the C++ bits, because of the threading, I thought I'd just mention how I built these things. I'm just using std thread, no libraries, no big layers of anything. Most of it is std threads, atomics, condition variables. There's a single header thread pool class that I've put a link to there, which is fantastic. You just drop it in and you can schedule work by passing in a lambda. It just does the job. And one of the foundations of my tool is this Moody Camel concurrent queue, which allows you to stick things into a queue and then pull them out at the other end without having to do any locking on mutexes. And it's incredibly useful and incredibly easy to use. And no project like this gets built without a lot of help. So this is my package list from VC Package, which I've said here is the package manager of champions. I was using various other approaches, but when I discovered VC Package, I didn't look back. It's unfortunately named. It isn't really Visual C only. It's a cross-platform package manager, which you kind of build yourself and just has so many libraries that just automatically install and work first time. And that's the full list, I think, of the ones that I'm currently using. The text editor. So as I mentioned earlier on, I wanted something a bit out of the ordinary. I wanted something where I could really go in and change how the text is displayed depending on what's going on. It also had to run in an OpenGL Vulkan or DX window, so it had to be able to draw itself in a graphics window, which is not as easy as you might think. There are open source versions of basic editors that do that, but typically you're looking at a client-server architecture if you wanted to use something like NeoVim, which is complicated. Also, I wanted Vim support. If it's a tool that I'm using to do a live code performance, I don't want to be stuck using like Notepad style editing. I just find that very frustrating. So that was something that I definitely needed, but of course with that comes the problem that I want people to be able to use it too, so I can't force them to use Vim, so the editor had to be able to switch between a Notepad mode and a Vim mode. As I said, I wanted it to have text adornments, places over the text where it could show interesting things, again to show this link between what you've coded and what you're hearing, and I wanted it to be able to show great error reports and warnings. So a couple of screenshots of it here. I'm going to demo it in a moment. You can see the screenshot on the left is the minimal mode that I mentioned earlier. Actually, it's drawing the visuals in the background, and the live coder is just typing code. And notice that he's misspelled uniform there at the top, and the editor has highlighted the line, popped up a tooltip, and told him exactly what's wrong. And that's something that I'm really picky about. I want to make sure that it works well and it's easy to use. Screenshot on the left is showing some Ixie-lang music, and the orange highlights are showing which notes are currently being played, and it's showing a split window and some syntax highlighting. So I'm going to go ahead and give a little demo of Zep now. So here is Zep, the integral editor. You can see it looks very much like a Vim tool. You've got the status information at the bottom here. It adds syntax highlighting. You can see one of the interesting features here, it can highlight the text based on what's playing. So this is actually feeding back from what the music is generating and telling me which notes are actively being playing, and I'll demo that later on. I can search for things. I can search for mandolin, for example, hop between buffers, search for connect. I can do all the usual Vim stuff. Let's delete 3 words. I can also switch to notepad mode, and then it just behaves like notepad. It's not modal anymore, which is obviously required for users who don't like Vim or don't use it. And there are adornments built in, all sorts of different ways to mark text. For example, add an underline here. Let's put another one in. And the tooltip here, of course, also a demo in this case, but enabling me to underline and highlight parts of the shader that are wrong so that the end user knows what's going on. And that's Zep, the integrated editor. So let's talk a little bit about audio, which is why we're here. Most of you will know that the typical starting point is this callback function that you get from your sound card driver or API. You're asked to fill in a buffer and given a number of frames, and you return that to the sound card driver and it sends it to the hardware, and so hopefully you hear something at some point in the near future. And on the face of it, it looks pretty simple, right? You can start making sine waves and hear nice tones coming out of the speaker. The first thing I found, which was interesting, was I was combining a few sine waves, and suddenly there was too much latency and the sound was broken. And I was like, well, I'm not going to get very far here. It turned out, of course, that calling sine at least on Windows in debug is really quite expensive. And by the time you've called that a few thousand times, you're starting to use up your CPU. So yeah, that was an interesting revelation early on. You can't use mutex in the sound thread. This is something I learned recently from Tima's talk a couple of months ago. I was using mutex. I was kind of getting away with it, but it certainly helped when I removed all of my locks and put in a spin lock for the small case where I needed it. You can't dynamically allocate memory. I am doing a little bit of that at the moment, but not intentionally. I need to finish sorting that out. And you have the problem of synchronizing what you're doing on the audio thread with what you're doing in the rest of the system. If you want to show the notes that are being played, or anything else that you figure out on the audio thread, you've got that synchronization problem where you can't use locking. So that's a hard problem too. The other interesting thing I immediately found was that using a stud vector was very slow, and that's because there's a lot of debug wrappers around that in Visual Studio on Windows. The easy workaround is to sacrifice the range checking and just make a pointer from the beginning of the container, and then you can walk around in memory regardless, and it won't do all the checks that it normally does. So just to think about this a little bit more, you have along the top here, this is typically what's going on. The sound card is reading the previous frame you sent and playing the music while you're filling up the next frame. There might be multiple of these. There's probably more than one deep stack of frames, but that's essentially what's happening. You don't really have much control over it. Last month's Audio Programmers talk did cover the new Linux Audio API, which has some interesting features, but generally you've got a buffer, you have to fill it in reasonable time, and that's more or less it. Because it's sound, there's not, you're making a bunch of sound samples to be played, that's all you're doing. But if we look at the bottom here, the interesting thing about this is that on a graphics chip, this problem is massively multiplied. You can have multiple buffers, they can contain different things, you can have multiple queues, you can assemble them on different threads. The GPU, you can pass the GPU barriers and semaphores to tell it when things can be accessed and when they can't, and to schedule things. And there are multiple hardware queues as well. The GPU can be copying memory from one part of its one region to another while receiving geometry data. So on the one hand, graphics is much more complicated. On the other hand, there are more options, more solutions to problems. And graphics chips are, obviously much more complicated than sound chips. That's obvious. That's why, for example, when a new game console comes out, it usually takes a few years before the game developers really start to push it to the extreme and get the best out of it. But yeah, I thought that was interesting that there's a bit of a parallel there. Obviously, I'm used to this problem of feeding GPUs, so when I started looking at the audio side, I kind of had a feel for what I needed to do and how to make it work. I've put a little link there for NVIDIA's Insight talk on GPU Trace, which covers all sorts of things about how to optimize using the GPU if you're interested in looking that up. So this is the next problem that I came to, which was generating just simple sine waves. As I said, I couldn't just call sine. You just don't do that because it's too slow. So then I came across this thing called wavetables. This is from the ear level website, which is a fantastic resource for this thing. And you can see he's got a little image there of all the wavetables he's generated and when they are switched between. But essentially the problem is that you can't just sample one lookup table for your sine waves, because then if you are sampling it at different rates, you will get aliasing. The solution is to make multiple wavetables and pick the parts of the tables depending on the frequency that you want to generate. Now, in graphics, this is very similar to something called mipmaps. We generate multiple resolution versions of the image, and then at runtime, the graphics chip is sampling them depending on the coverage on the screen of the texture map to pixel ratio. So if the texture is is on a rock at the back of the scene and it only occupies 3 pixels on the screen, then you're going to pick one of those tiny little images. But if the rock's right in front of the player, you're probably going to use the high resolution image, and they are filtered and switched between using mipmaps on the graphics hardware. And the reason for that is to stop aliasing. It's the same problem essentially, except it's visual aliasing versus audio aliasing. So that was an interesting comparison I came across, and there are some links there if you're interested in following up on that. So once you've generated sine waves and you've got that running nice and fast, it gets a bit boring. They're not very interesting to listen to. And so the next thing was, where do I go next? How do I learn something new about audio to make the kind of sounds that I wanted to make? And I discovered after a lot of searching these great resources. There was somebody on the last meeting talked about AudioKit, and that uses internally a DSP library in C called SoundPipe. And these two things combined really gave me all the knowledge I needed in order to generate pretty sounds. AudioKit has this great sample code where it calls SoundPipe and it builds a pipeline. The AudioKit Synth 1 application is, you can get all the source, you can just read through it, and you can see the example I've posted here. They're doing some oscillation, some panning, some phaser and crossfade, and it just shows you, what parameters to use, how these things work. And there's all sorts of little tricks and tips in there that I would never have known without a reference. Just different and interesting ways to do things. So yes, once you've got to that point, well, at least once I got to that point and I was generating nice sounds, I wanted something that was configurable. I want the live coder to be able to say, today I'm going to have this weird and wonderful synthesizer with 4 oscillators feeding into this low-pass filter and doing this and that and the other. And I wanted them to be able to configure that perhaps before the performance, or maybe even during if they're brave. So I wanted to build a graph, essentially. If you're familiar with this kind of approach, this is Bitwig, for example, where they have a tool inside of Bitwig. I'm not sure I can remember the name of it, but it allows you to drop these blocks in and connect things together. So this is a triangle wave, and it's fed into some kind of envelope and then fed to the output. And you can have a lot of fun playing with this. I actually love Bitwig. I think it's such a beautifully designed app, and the UI aesthetic pleases me greatly. And I actually copied the way the buttons, my my control knobs work from Bitwig. And mine are similar enough that I'm almost convinced that they're using the same graphics library as me. But anyway, so that's one use of graphs in the audio industry. This image on the right is actually an output from my graph. I have a script command which can just drop a created graph onto a website and display the connection information of how the graph is built, which is great for debugging. So how does a DAG typically work? There's directed acyclic graph. At least in my system, the way this works is I start at the output and I walk back into the graph evaluating all the inputs. So if I'm at the mixer here, I might think, okay, can I run the computation of this mixer? And then I look at my inputs and realize, hang on, they're not updated yet. They haven't been updated for the current frame. So then I walk back into the parent node, the oscillator, and the oscillator doesn't have any inputs, so it generates its data and validates this blue arrow's worth of data. The ADSR does the same thing, and then eventually the mixer can then run. So in a directed acyclic graph, you want to run every node once, and that's the basic approach to generating a graph. It's powerful because the user can lay out a graph of nodes how they want, and you just figure out what the output node is and walk back into the graph. And as you evaluate it, once you've finished, you have your sound samples. That's the theory anyway. Graphs are interesting because they're used in graphics all the time. This is quite an old image, I think, from a few years back, so you can imagine where they're at today. But this is the rendering graph from the Battlefield 4 game, and you can see all of the nodes here that are building up this scene. And I don't know what they're doing. Perhaps they are generating lighting effects, working out depth information. They come together eventually to form the final frame of the game, which is probably this right-hand node right at the far end. And they had built a debugger to, there's a talk about this at GDC, I think it was, that you can go watch if you want, but it talks about the complexity of building this big complex game using a graph. So yeah, graphs are something I've worked on before. I'm very familiar with how they work, and surprisingly similar concepts. Another tool in graphics is called Maya, which is a CAD application, and internally that uses a scripted graph, which I have used a bit in the past to write plugins. So this is a bit of a closer look at my graph. You can see here I'm showing the same thing, a slope and an oscillator being fed into a mixer. I have some mechanism to get the data into the graph from the timeline or from a lock-free queue, and it sits in this pool of notes in the graph, and this is basically keeping track of what notes are currently active and playing. There are inputs to some of these units using portamento, so that if the user twiddles a knob, it doesn't immediately switch. It catches up slowly in order to make the user interface to the synthesizer clean and not sound jerky when you're adjusting things. So yeah, I've showed some inputs here, and then once this bit of graph is evaluated, it can output two different types of information. The ADSR is outputting control information, which is control slopes for controlling the volume of the sound. That's what this one's doing. And I have flow information, which is actually a polyphonic bundle of audio. So what happens is at each tick, the graph has to sample all the notes at once and make sure that it generates channels for every active playing note. So each compute step in each node in my graph has to do all the work for all the notes at the same time. And essentially this mixer here is taking two types of input. It's got the control and the flow input, and the control is going to use the slope to modify the audio channel, and out of the mixer at the back end you'll still have those polyphonic channels, but they'll all have been mixed using the control slope. This is an example of, pseudocode of how it works inside that oscillator. It looks at each note. It creates a channel for each note, which is fast because it uses a memory pool to cache channels inside the graph. And then it walks the frame count of the audio, samples the wavetable, for example, and stores the output data. And it's doing, as you can see, for each note, for each sample in the frame. So it's doing all of that work at once and outputting those channels. Sometimes there are two channels and they represent stereo, but often there might be many, all bundled together. So how do I handle modifying the graph. This is a problem that I became aware was fundamental in audio. Is if you have your graph running, how do you change it? I looked at Super Collider. Super Collider does it, I believe, by sending messages from the UI thread into the audio thread, which are effectively instructions for how to modify the graph. I didn't choose to do it that way. I modify the graph outside of the audio thread, essentially making it dormant for the time I need in order to edit it. And I'll come up with quite a clean approach to this, I think. What happens is the graphs are all running in the audio thread here on the right. The first thing the audio thread does is spin locks. It does a try lock, which doesn't actually take the lock, it just spins and waits. It doesn't do a mutex lock, I should say, but it will spin until it can get a lock on this mutex here. And then it'll process all the active graphs, and then it'll free the lock. But this is engineered so that this try lock is very minimal. It almost never happens, in fact. The reason it never happens is because on the UI thread, on the other thread, it's doing this thing where it does a lock, marks a graph inactive, and then frees the lock immediately. So what the threads outside of the audio thread are doing effectively are saying, okay, I need to change this graph. The user's just rerun the script. What I'll do is quickly mark the graph as being inactive using this lock, and I'll only take the lock for a moment. And then once it's done that, the audio thread side will no longer play that graph if it comes in for another audio cycle. This means that really the audio side is never waiting. But there may be occasions where the audio side does not have a graph to play when asked for frames. Now that will only happen if the user is rebuilding the graph, essentially tearing apart and rebuilding the synthesizer. So that's not a problem. That's how it works. There might be interesting ways in which I could make this delay until the synthesizer's quiet and all that sort of thing, but I haven't thought about that too greatly. But this does the job really, because typically people are building synthesizers before they start playing the music. But yeah, this is an interesting way to ensure that the graph is never modified while it's running inside the audio thread, and the audio thread is never really waiting to be able to use the graphs. Yeah, so an active graph is on the audio thread. If it's inactive, it's on other threads being manipulated. If a graph is awake, it requires compute. But if it's asleep, it can save all of that work. There's no point running a graph just to get a bunch of zeros out on the audio channel. So when is a graph asleep? This is something that I've wrestled with a bit. I think I've got a reasonably good solution now. You could say that the graph is complete when the slope, the ADSR slope, is finished. That would be one approach. You could say that it's finished when there's no more sound coming out of it. There's a danger there that some effect unit is about to cycle round and play something again though. You could say when an effect is done. For example, if you've got reverb and you know the reverb is adding another half second or something, then you could say, okay, I need to finish in a half second because no more notes are coming in. Or yeah, when the user says, there's no reason why script code couldn't tell these things to go on and off at some point. In practice, I use a kind of a combination of all four. Effectively, all my nodes in my graph are allowed to say, please keep this node active when they play. And effects are also allowed to say, I want time to run for another 3 seconds after all notes are finished. And there is also a back-end check to make sure that that synthesizer isn't playing. There's a danger, of course, that with all of these mechanisms, you might find a graph that is continuing to play and consuming resources when it doesn't need to, but I consider that really a bug. There should be some reason why the music slows down or finishes, unless it's a graph that is designed to just keep playing continuously, something that has a delay. So yes, Janet scripting. This is how I build the graph. As I said before, it's a Lisp-like scripting language, very simple and easy to use, very easy to embed. It has a great foreign function interface, if you know what one of those is. And it's easy. It was an easy step along the way to building graphs. Eventually, I want to get to the point where, like Bitwig, where I can drop nodes using the mouse and drag lines between them and build synthesizers that way. I think that's always something I've wanted to do and never quite got there. I've got a long way along that route now, and I'm pretty close to being able to do that. But this was a very simple way to get the graph building without having to worry about building the visual tool first. So in this example, I'm creating a simple synth, and then I'm adding an oscillator. This FM up oscillator is basically 2 oscillators where the frequency of one is being modulated by the other. And then at the bottom here, I define that synthesizer and I just play it. And I'm going to give you a demo of that. Let's go a little deeper here and just play a little with the Janet scripting language. You can see here, it's quite Lisp-like, but very easy to follow. This particular part of the code here is building an output graph. I have the concept of a graph which runs after all the other graphs. And that's where I do the mastering and add the audio analysis. The audio analysis can be put anywhere in any graph, but I always have one on the output so that I can see what's going on. So if I just evaluate this, there's our little output graph. We see the mastering node and the audio analyzer, which isn't getting any audio. But let's go and make another simple script. This is a very simple one here. This defines a simple synth which is made up of an FM oscillator which has one oscillator controlling another. So let's define that and let's play it. I can also just hit keys on my keyboard here and yeah, so 2 oscillators. I can play with the attack curve in the UI, of course. And I can also send commands from the script. Let's do something a bit more interesting. There's a function here which adds a special effect path. So we'll define that first. And then here's an analog synth. And this is a specialization of that analog synth, which creates this what I've called dark sci-fi synthesizer. I can also hit keys on the keyboard as before. And of course I can still tweak things. I can turn the sub oscillator up, change things as I go. I've got the delay on there and the reverb you can hear. Turn that off here. Maybe add some FM synthesis into that as well. So yeah, that's the Janet scripting. There are lots of examples in here and I need to build more interesting things. I have some things where I build a DX7 style of synthesis just because that growing up that was something I knew. Here's a function that builds 3-on-3 operators. Let's try that. These are various functions that set it up. Oh, here's a flute. Let's do timpani drums. And there is the synthesizer that was built. You can see all these different oscillators feeding in a different way. It's quite effective. You could probably also notice the notes flowing along the filters here being fed back. And I can zoom in if I can just find my mouse wheel. Eventually this will be a full graph editor where I can drag and drop things and connect things together, but at the moment it's showing the control surface view, which allows the artist to tweak the synthesizer while it's playing. But that's the Janet language. One of the challenges, of course, of UI is how do you communicate with the audio thread. This is one approach that I've took. I called it lazy memory originally. I'm not sure if I'm still calling it that, but effectively, on the audio thread, when this is the case for these little blue dots, which are representing the notes where they currently are on the ADSR slope. What happens is in the audio thread, it reads. It has a buffer, a pair of buffers that it's working on. The audio thread has access to one of them at any one time, so it gets the right buffer. It writes to it without locking. It knows that it can always access it, and then it does a try lock. If the try lock fails, it just throws it away and forgets about it. If the try lock succeeds, it swaps the pointers, and now the write buffer becomes the read buffer. So what this is doing is essentially ensuring that the audio thread runs in constant time and never waits. The disadvantage, of course, is that it might throw away information about where those notes are, but that's okay. On the UI side, it's locking the read buffer. It does a proper lock. It reads the notes and processes them. They may be old because the audio thread may not have swapped them, but that doesn't matter. It's just going to show the previous position. This is happening so fast that as long as those notes update, even 60 times a second or whatever, or less than, you're never going to see the difference. So this is an approach I've used in order to make sure that the UI can always run and show something and the audio thread is never blocked, because I don't care about perfect accuracy of showing this note information. I use the same approach for the FFT. It's slightly modified in that the audio thread now puts the audio frames onto a lock-free queue. This queue is fed until it's full. If it's too full, it won't even bother doing that. The FFT processing thread wakes up periodically, pulls things off the queue again because it's the lock-free queue, updates the audio processing, and then the same approach as on the previous slide happens, where it tries to write memory, but it will discard it if it can't. Excuse me. And so on the UI thread, the same thing as before happens. It always locks and reads and processes. It might well be processing old audio data. In practice, it almost never is. It's very hard to see this ever happen on the profile. So there are just a couple of approaches I've taken to connecting the UI to the audio. Yeah. I have a regular tick in the system. This is how I manage patterns. Obviously, the user might be creating musical scripts which contain lists of notes to be played in a pattern, and I need to schedule these things. So I need a reliable timer, and this is the best one I've found so far. Essentially, there's a thread running which sleeps for a given amount of time and then wakes up and then ticks all the consumers, and then it sleeps until the calculated time for where it should wake up. It doesn't sleep. It wants to wake up at a regular interval. It doesn't really care how long the middle part of this takes, but it should always wake up at the same time interval. And in my measurements, I've had microsecond drift when doing this. Certainly no more than a millisecond. I think 700 microseconds rings a bell, but it doesn't drift very much, and it's the best I've come up with so far. Obviously, this is only scheduling information. It doesn't have to be perfectly in time, because the notes are also picked off at the right time in the audio thread when they're being played. This is an example of pattern scheduling. This is still somewhat a work in progress. It works. You'll see in the demos it works, but I still am not happy with the design. But essentially what I have is external, maybe a MIDI keyboard. I might have Orca, which I'll mention briefly later. I have Ixilang. They're all doing timeline updates, and what they're doing is they're putting notes on the end of this ring of data, which contains all of the notes that are scheduled to be played. You can see the blue line in the middle of the visualization here is time zero when they have to be played. So these are all in the past. These are the ones that are just about to be played. And what's happening is the UI thread is consuming the back while the other threads, the timer threads, are producing notes. And the audio thread is doing exactly the same thing. Now, interestingly, they might end up not quite scheduled at the same time. The UI thread might be behind for whatever reason, but that doesn't matter. They're pretty much the same, but there's no lock between them. There's no link between what the UI thread and the audio thread are doing. The audio thread is basically sampling the notes that are upcoming and figuring out when it needs to play them. And as long as these two, this consumer and producer in the ring buffer, never collide, we're all good. This is kind of the design I've gone for. It's not quite right yet. It does work, which, tends to make, I just leave it alone and work on the next complicated problem, but that's where I'm at with that. Yes, I mentioned Ixilang. It's a powerful music language. I wrote my own parser for it because it's fairly trivial. It's great as a beginner synthesizer sequencer for the synth, and Jibber actually used it as their inspiration for a music language. I think it's underused, and it's definitely something worth looking into. So Janet isn't the only thing that I can use to sequence music with. Orca is something else that I've been looking at. This is an esoteric programming language. It allows you to build these little cellular automata programs that can run and schedule notes and fire off events to the sequencer. I haven't got this running at the moment. I have had it running in the past. It's a lot of fun to play with, and it's potentially going to be another way in which you can schedule notes. I just thought I'd show it because it sits inside the editor. It's already implemented in there. Music and graphics, yes. How do we connect the two together? There are several ways, but essentially you need to get the information about what the music's doing to the GPU in some way. So the way that I approach this is I convert the music to frequency bins using a fast Fourier transform. That happens on a thread, as I mentioned earlier on. And those frequency bins are then converted into a 4-row texture, which you can see here expanded out. The top 2 rows are audio data, the bottom 2 rows are the frequency analysis data. And because they're in a texture, the graphics chip can sample those and use them in any way it sees fit, which is great at the pixel level per pixel on the screen. The image on the right is actually a pixel shader, which is sampling them and drawing a more traditional equalizer, which obviously runs very fast in a single frame. It's just a single, well, it's a pair of triangles drawn as a quad. Very easy to accelerate for a GPU. It also converts the frequency bins into a 4-component vector, and that's used in the vertex shader in order to modify geometry, which is useful if you want to have things bouncing around on screen to the music, for example. There's a problem here though, which is all about latency really. How do you get that data in reasonable time? The issue is if the microphone hears a sound, but the visual only updates a fraction of a second later than that, then it's really easy from a user's point of view to see that disconnect, to hear the audio and see something. It's like bad lip syncing on a TV movie. And there are all sorts of reasons for that. There's whatever the audio hardware is doing, the size of the frame that's being captured, the size of the binning that you're doing on the Fourier analysis, how fast that is, how long it takes to upload the texture to the GPU, how long it takes the GPU to render the frame, and then the v-blank sync, which is if the screen is locked to a refresh, or if you've got a frame a frame per second cap because you don't want to run too fast and starve the system of resources. So there's a lot of things going on that can mean that the distance between the microphone and what you see aren't always the same. And the worst case for this is a microphone, which is sitting in a room listening to music, and then which some live coders have. And then you can see that the visuals aren't quite synced to the audio. That's why often when you go to these things, people will do visual demos that are more ambient, which pick up the general feel of the music, but don't tend to bounce along to the beat. Not often anyway, because it's a harder problem to solve. It's not unsolvable, but the nice thing about this system that I've built is it's an integrated system where I have first-class knowledge of all the pieces, which makes this a little bit easier to solve. One thing you can do as well, which I intend to do but haven't done yet, is you can insert a delay between generating the sound and sending it to the driver to give the graphics a chance to catch up. And it sounds funny to say that the graphics needs to catch up, but typically that might be the case. If you have a really slow shader running, at only 10 frames a second, your actual limit on those visuals is what's causing the visible delay. That tends to be the critical path in my experience. If I whack up the frame rate of the graphics to a few hundred frames per second, I can pretty much get the audio and the visuals to sync up exactly and look as if they're happening at the same time. So that's an interesting problem. One way in which I can look at problems like that is with the built-in profiler. Graphics tools often have a scribble like this, as I showed right at the beginning, in tools that I've written in my day job. And so it's something that I've written actually many times before, so this wasn't very difficult for me to do because I knew all the ins and outs of it. This is an example just shown here of what might happen if the audio takes too long. So for some reason there's a blockage here. The audio has taken too long. This frame of the UI is 35 milliseconds, so the audio is probably just over half that. And you can see what's happened. The audio hardware has gone, oh, I need more data. So it's started to ask for more and more frames, and it keeps asking until it catches up, and then you get a gap. And so this is the sound card driver doing the right thing and making sure that it's going to have enough buffer so that it's not starved. And the vertical distance here, it represents what I think should be the longest the audio should take in order not to starve the hardware. This is all the audio catch-up I just showed. This is a closer look at a graph. You can see all the sub-nodes inside the graph being evaluated in parallel on different threads. This is an example of something that I found when I first built the profiler that was incorrect. The spectrum graph was waiting and the UI was blocked. And that shouldn't have happened, and it wasn't how I designed the system, as I showed earlier on with the lazy memory approach. But there was a bug, there was something that wasn't doing the right thing. And it only became apparent on one particular frame. This is actually a zoom in, but it only showed up by grabbing a few thousand frames and looking and seeing, why is that one taking longer? So that's more or less it. I just wanted to cover what I'm thinking about for the future. The first priority is obviously to get this into people's hands so they can play with it. I love building tools. I love to see what people do with them. I think I will consider it a success when I see somebody live code using it. I'd like to implement the session recording that I mentioned. I think that's really nice. I would love to be people to be able to say, hey, look, check out this live coding performance, and just send you a project that you can load and watch on your local machine, or record something that they did the night before and figure out why it sounded so good at that point. Visual graph editing, as I said, I'd like to be able to drag and drop nodes and hook them together. I think that's a fun thing to do anyway, both for graphics and for audio actually. Geometry generation, at the moment I'm just drawing spheres and toruses and things. I can use a geometry shader. I haven't tried that for a while, but I'm sure it still works. But I would like some way to script the graphics more so that I can generate all sorts of interesting primitives. I'm interested in music languages. I think there's a lot of interesting things that can be done there, especially once you've got to the point where you've built an IDE that has a pattern runtime, can efficiently schedule things. I hope that people might take the tool and just say, hey, I'm going to go use it to experiment making a new language. I think that would be awesome. I'd like to get DX12 and Vulkan. That's kind of more in my wheelhouse, and I'm really interested in shader editing and shader authoring. And ray tracing and VR. I've thought, wouldn't it be cool if you could have, a VR environment where you were live coding, and that's pretty cool. And because of the way that I've built all these pieces, it would lend itself to that. It could be dropped in. The editor obviously can sit inside a 3D world and all the pieces. I suspect I could get there with that if I had the energy. We'll see. And that's the end of my talk. Thank you.
Thank you, Chris. Wow, this was really, really impressive stuff.
Thank you.
Yeah, I mean, obviously you've done this a huge project, but thank you so much for giving us a glimpse under the hood, how all of this works. And I think it's a mixture of I guess anyone who's built an audio engine before has bumped into some of those problems before, but seeing your solutions to it and just the whole picture, and also your particular solutions, that's super interesting. And just it's a massive project. It's so impressive, how you just put this together. So yeah, definitely very impressed. Thank you for sharing all that.
Oh, thanks for saying that. It's a fun. I could have talked all night about it, I suspect. And I had about twice as many slides, I think. Yeah.
I do have a question. How long did it take you to put all of this together?
It's many years, actually. It's not a short project because I only do it part-time. So as I was saying to Josh before we started, I get up in the morning, I go out early for breakfast. I take my laptop and most of it's written in a coffee shop before I start work in the mornings. And I usually get the day on Saturday or some big part of the day on Saturday while my children are at school. Poor them. Yeah, so it's taken a few years. The editor was a sideline, a tangent that I went off on, which took a full year of part-time work just to build that piece. The graphics stuff some of it is all ancient, little experiments and old things I did. Some of it needs reworking by now. And yeah, the audio probably took it's probably a year of part-time work to get the audio stuff done. The UI looks complicated, but I've done that kind of thing throughout my career. So for me, that isn't the hard part. The hard part is the generating the audio and figuring out how to play the audio graph. And that's why I concentrated on that. But yeah, it's a multi-year project, several years, in fact. And there's no clear defined end, right? It might be finished next year or the year after. And it, it depends on the energy I have and how well things go.
Yeah, that would have been my next question. Like, when is this actually going to be, out, and like when can you get our hands on it? But I guess, yeah, you just answered it. Like,
yeah. I mean, my preliminary, my work in progress is that I want to have something shipped by early next year. There's a difficult problem here, right? Because it's all going to be open source. It's all free. Parts of it already are shipped. The editor is already out there, and people have dropped it into their own engines and done things with it. But yeah, the idea is to get it in people's hands, because once it's open sourced, I might get some help, which would also be great. But I don't want to open source it and then have it not be finished well enough that people can't get something out of it. The worst thing to do would be to ship it and then have the bugs get in the way of everybody, and everybody kind of walk away from it and say, oh, I can't use this because it's not right yet. But it is modular, so the audio project is an entirely separate application that I can just run without the graphics. So I'm thinking that I'm going to just ship the audio first, and you'll be able to play with the synthesizer stuff and the note sequencing without generating visuals. If I do that, it'll give me, another few months to make the graphics really great. So yeah, that's what I'm thinking. But there will be some of it shipped next year for sure, especially the audio part.
Mm.
But I'm not putting that pressure on myself, because obviously I have a day job. I have a lot of work that I have to do in that. And so I can't, that has to come first, obviously.
Well, yeah, thanks. I'm really looking forward to this coming out at some point. I definitely learned a lot from, just you talking through these problems that you solved. It's really, really so interesting. We do have quite a few questions from the YouTube chat.
Sure.
So Igor Abdul Aguilar asks, what are your thoughts about pure data, vanilla, for live coding?
It's really cool. I'm on a Slack group called The Future of Code, where they talk about all of these kinds of tools, building software using dragging and dropping blocks and all that sort of stuff. And I think pure data is great. I did kind of allude earlier on to the fact that a lot of these tools are sometimes not easy because they're all open source and they're not finished. And pure data is one of those that wouldn't run very well on my machine. It isn't high density aware. So I've got a 4K monitor. I run pure data, I can't see anything. And I'm forever tweaking fonts and stuff. So I'd love to play more with pure data, but until they, sort it out and make it work well on my machine, then I won't. I've got a MacBook, so I have dabbled with it, and I think it's a fascinating way to do it. And I've seen live coders use that and tools like it. So there's a paid version as well called Max MSP, which I've never seen, but I hear is very good. Obviously, because they have to pay for it, I haven't purchased it.
Right. So Joe Black is asking, have you considered doing audio and DSP on the GPU?
Yeah, that's a fun thing to do, right? I haven't done any research in that area. It might need bigger brains than mine. I don't know. I mean, I've done graphics programming, and I'm capable of looking into that. But if I went down that rat hole, I would never come back, I suspect, and I'd never get the thing finished. So, right.
Thank you. So George Conturas is asking, how does one get into a complicated API like Vulkan if you only have some OpenGL experience?
I would start on the tutorials. There's a fantastic tutorial. I think it's called Vulkan tutorial. If you Google it, it'll be the first hit you get. They've got a really great one. Vulkan's hard, right? DirectX 12 is hard. It's not for the faint-hearted. Even if you've done OpenGL, it takes like 1,000 lines of code to draw a triangle on the screen. To get your first thing on the screen, you actually have to type 1,000 lines of very complicated code, and you really have to understand what they're doing and what the hardware is doing in order to set it up. So yeah, I'm not to discourage anyone. I think graphics programming is fascinating. I hope I conveyed that in the talk. But yeah, I would start with the Vulkan tutorial. That's definitely the place I would go first, and just do it. Just get on with it.
All right. Okay, we have a couple more questions. So John Rupsch is asking, it seems like your understanding of audio coding really benefited from truly understanding graphics first. So would you say that understanding audio is beneficial for graphics, like the other way around?
You're asking if audio has taught me anything about graphics?
I think I'm not sure I understand the question 100% right. I think they're saying that obviously, like, your understanding of audio has benefited from doing graphics first, and I guess they're asking whether that's the case and whether you think that's also the case the other way around.
Yeah, I did actually see that question as it went past on the chat, and I think that was probably before I had demoed some more of the parallel cases between graphics and sound. So in that direction, certainly, when I've encountered wavetables, I was like, well, this is just mip mapping. It's just audio mip mapping and not visual mip mapping, and also my knowledge of program, because I used to write drivers for GPUs, so I've got quite intimate knowledge of what the hardware is doing. So when I see an audio API that says tick, give me some frames, I know in my head that what's happening here is that this buffer is some kind of shared device memory or something that's going to get DMA'd to the hardware and how it's going to consume it and how it's going to manage the timing of that. I've got the knowledge of those things, so that helps with my understanding for sure. Did I learn anything in the other direction? Probably, yes. One of the main things I learned is how to do better threading code. I'm still learning that. I mean, I've talked with you, Timo, on Discord about problems I've had in the past, but I've become a much better C++ multi-threaded programmer now. I think that I can write stable threading code now that I couldn't do before, because although we do a little bit of that in my day job, nowhere near what I had to do to make this work. So yeah, there was a bit of, in terms of a learning experience, I would say it's been great.
Yeah, that makes a lot of sense. Actually, I think that's something interesting maybe about the human brain. I don't know. I find that often when you like read a book about audio, or I do that sometimes in my own talks when I just explain like basic audio concepts, that you kind of use like an analogy and like this is the analogous thing in the graphics world, and that tends to like help a lot of people understand it. And you actually had quite a few of those in your talk, which were completely new to me, like the whole mid-maps thing. It's like, wow, I've never heard about this, but this is really cool way to explain what's going on. You had quite a few moments in your talk like that. So
yeah, and mip-maps have been around since texturing was invented. Mip-maps have been around forever, and these days we do all sorts of even more complicated and interesting things along those lines. But yeah, it's good stuff.
So finally, we have one more question by Aaron Smaltkes, who's asking, what do you do full time? Like, what do you actually do in your day job? If you can share anything about that at all.
Well, I pointed at the beginning the slide, I think slide number 2, which you can go back and look at. I've worked on tools like Nsight recently, which is a graphics debugger. So you running your game and something looks wrong in a particular frame of your game, or there's a particular frame that's running slowly, and you can fire up this tool, grab a frame of the game, and then look at everything that's happening on the graphics chip and in the API. So in GPU Trace, you can actually see what units in the graphics chip are busy, and so then you can figure out why the code you've written is running slowly. In Nsight, you can look at the contents of the frame and figure out, that triangle you drew was bright red and it shouldn't have been. You can get down to that kind of level. So I write tools like that. I actually was the first developer tools person to work for NVIDIA. When I first arrived, I remember somebody asked me, what, you're just going to talk to developers and that's all you're going to do here? So yeah, and actually, you're going to write tools, because there was nobody hired just to write tools when I arrived. So that's what I've done for my whole career. I love to write tools, and I hope that's obvious from the presentation. I like to put tools in people's hands that make their life easier, and I just find that a really interesting thing to do. So that's what I do. Yeah.
All right.
That's awesome. And so you said that you had some stuff that was already open source. So what part of this is open source at the moment?
Just the text editor, the Resonality bit. There's a GitHub organization that I created called Resonality, and underneath that, I can put a link in the chat, I guess, is a shared C++ library, which is just my grab bag of bits, called utils. And it used to be a library that built the world. It used to build all of these projects like Port Audio and OpenSSL and these horrible to compile C++ libraries. And it used to be my central source. And then VC Package came along and just removed that whole problem. But yeah, so there's a shared library. There's the text editor called Zep. And if you just Google Zep GitHub, you'll find it. And it has pictures on there of various things that it does. And that, these are all works in progress. Don't go away and think that that is finished, because it isn't. So yeah, and then the audio stuff and the visuals will come out later next year, as I said.
Yeah, one thing that I was thinking during your discussion was, and is something that I always think about because I come from kind of a high level using Juice as a framework to create my plugins and audio apps. And I've always wondered what happens under the hood or how you work from the bottom up. And I think this talk has been really helpful for me because it really let me know some of the work and some of the thought processes that go on a couple levels below what happens at the framework level. And another question that I have was just around working with the different APIs, because you said that this is a cross-platform system. So you must be working with Core Audio and Wasapi separately. And what do you find are the biggest challenges of working with those different APIs, setting this up for Windows versus setting this up for Mac platforms? And what are the differences in dealing with those APIs?
Yeah, so specifically the audio case, I don't actually talk to individual APIs. I use a thin layer called Port Audio, which basically gives me a list of audio devices and audio APIs and lets me pick, and I can say, okay, on this system, use Wasapi and give me, this many frames and this, and it just gives you back that callback that I showed at the beginning and asks me to fill in the sound buffer. So I don't go that deep for those things because it would just be a nightmare, right? If I had to write all these use all these different APIs. To be honest, the biggest cross-platform challenge is build systems. As I was saying earlier on, I probably spend a quarter of my time editing CMake files, making GitHub Actions work properly, making continuous integration work properly. All of that stuff just takes a lot of time and effort and maintenance, but you have to do it. If you want to build a piece of software that everybody uses, you have to be compiling it for all platforms on every check-in. And once you get to that realization, you are pretty much going to have to be a CMake expert, and you're going to have to be a GitHub expert, and you're going to have to be a scripting expert. And so that stuff takes a lot of time and effort. That's the big effort with cross-platform. Once you've got to the point where you understand the basics of cross-platform coding, that's not such a big deal, right? Occasionally there'll be some compiler difference, some small thing, but if you keep it generic, usually that's not the problem. It's the systems around it that are hard, I would say.
Yeah, I mean, this completely echoes my experience as well. I'm working on a project right now, which is also cross-platform. We also use CMake as the build system. And like the actual differences between the platforms, if you have a framework that kind of wraps them, that's not very often like the cause of the problem. It's like CMake, CI, like all the kinds of like scripts you need around that to make things work, and like all of this stuff. So it's interesting to me, like on a high level, like, it seems that many projects that kind of like build something like an audio engine, they bump against like many of the same problems, like what you talked about with like thread synchronization, and then obviously now we talked about the build system and the audio graph. Like it seems that a lot of people are bumping against the same problems, but then you kind of find slightly different solutions to it, and it's really, really interesting because every time someone talks about like how they actually implement like a whole big system which contains an audio engine, like there are always these like differences, and like, okay, there's a slightly different use case here, and then you just take this other approach here, and it's just really quite interesting. It's just maybe like a meta observation rather than a question, really. But
yeah, no, it's true, and part of the fun of all of this is discovering how to solve those problems for yourself, right? And that's why I don't use Juice, right? Not that Juice isn't awesome, but for me, that takes away part of the fun.
Yeah. And this is like, apart from like just being amazed at how much work you've done and how impressive this all is, like the other takeaway for me is like, obviously, I'm working on an audio engine, and like, I'm like, maybe we should consider this, and like, I guess that's kind of why it's like so valuable to have these talks where someone talks about like how they actually implemented stuff, because you get to like see these different solutions and see if they apply to your problem and learn from each other, really. I find that really cool. So thank you very much for just sharing all this.
Yeah, sure. And as time goes by, I think things do get better. That's the interesting thing about this. When I started off trying to build all these complex libraries, and then VC Package came along, and that really reduced the amount of work I had to do. And then another ray of light was when Travis started charging for their continuous integration, and I had to learn how to use GitHub Actions. And then suddenly I'm like, oh, GitHub Actions, they just work, and they're much easier to use. And so, you live and learn, don't you? Well, a friend of mine says you live and learn, and sometimes you just live. But it's true.
And also, I'm very relieved to hear that other people spend a quarter of their time on maintaining build systems. So that seems to be a common problem.
Yeah.
I have one more question before we move on. I mean, it seems like you're dedicating quite a serious amount of time to actually doing this project, and it's the type of time and the type of effort that I think a lot of people would charge for. So I'd like to know your motivation for making this an open source project. Where does that motivation stem from? Where you say, okay, I'm going to put in all of this hard work, but now I'm going to open source it and I'm just going to give it away to people to use.
I think part of it is, as I said, I just like to build tools. Another part of it is that I've been at NVIDIA a long time and they've been very good to me. So I'm not looking to, make a fast buck on some side project. That's kind of not where I'm coming from. I'm doing this because it's something that I really love to do. And if you look at my website, which I showed a screenshot earlier on, I'm always building something, and my biggest problem, honestly, is to tell myself to stop coding so that I can go eat and live the rest of my life. So, I'm always fascinated by something new, whether it's advent of code, which I started doing this month before I realized it was insane to do that, and this talk, and keep on top of everything else. So there's always something new to do, but I enjoy it. So there's no reason not to give it away for free. What would satisfy me would be if people used it, if it became part of the scene where I went to an algo rave and a couple of the guys on stage were using it to make music. And I think it would be very hard if I said, I'm going to charge for this application. Probably no one would use it then. But if I make it open source and free, it might actually become something that people use. And then I can, smile proudly and watch it go out into the world, which would be great.
To me, it sounds like it would be a great educational tool for people that are trying to get a level lower than Juice and really learning how the nuts and bolts of audio programming really work.
Yeah, I think that's true. I hope that's true anyway. The FFT, for example, there's a page of code in there that shows you how to do an FFT in C++ when you've got the audio buffer from one end to the frequency bins. And at the beginning, that was really hard to find. I found little fragments on GitHub, little pieces of information from people. But, working through those problems, figuring out the decibel conversion, the Hamming window, the way that you convolve the data, all that stuff is hard. But once it's done and there's a page of code that shows you how to do it, then it's never going to be hard again. So I hope that stuff will get out there and people will look at it. It's not all great code, but I don't tend to release it until it is. So hopefully it'll be okay.
Amazing. Great. I think it's a good time for us to move on. Thank you very much, Chris, for that talk. That was so educational for me, and I think for a lot of people that are joining us as well.
Thank you. It was great to have an opportunity to show it off. So I appreciate it. Thank you.
Fantastic. Okay, so now we're going to move on to our speaker session, which every month we do one presentation, and then we also do an interview where we try to go beyond just the technical aspect of what people are talking about in code and trying to discuss a little bit more behind the scenes. I've actually named it this afternoon. I came up with a name for it, which is Beyond the Code. So what we're going to do is we have our guest here, Kevin Mulcard, who is the VP of software. No, you're the director now of
director of software development.
Yeah, at Arturia. Welcome and thank you for joining us today.
Thank you for inviting me.
Yeah, so it's great to have you here, and I think that a great place for us to start would maybe to talk about a little bit about who you are, how you got into audio, and how long you've been in Arturia.
Yeah, I have always been passionate about music, and when I was a teenager, I started to make music with my friend and to make computer music. So I started in the end of the 90s, playing with the first version of Ableton Live, Fruity Loops, stuff like that, and making techno music with my friends. And then after the high school, I wanted to become a sound engineer. Unfortunately, I didn't manage to go to the sound engineering schools because I haven't that much experience in sound recording and things like that. But I was good at math, and so I talked to a bunch of people, and I said, okay, I like to play and to make music with this kind of software. Why not trying to become a software programmer and making this kind of software? That would be a great things to do.
Yeah.
And so I did I went to the university and do a computer classroom, and I went up to the master's degree. And then I looked at a very famous website in France called Audiofanzine, which is a place where all people passionate about music can look at, and you have all the companies and all the product available. And I took all the companies that were doing software at the moment, and I sent my resume and applied for my last year of internship. And fortunately for me, Artoria answered to me, and I come up at the company as an intern.
What year was this?
Sorry?
What year did you join as an intern?
Sorry? Again?
What year did you start at Arturia?
I started to work on the Origin project, which was the first Arturia hardware synthesizer. It was back in the 2002 and 7. And yeah, I started as an intern working on the software, on the updates of the firmware of the hardware, and also the software that manage the presets, so you can send back from the computer to the hardware the presets. I worked on that for maybe 2 or 3 years. Then I started to work on the Spark project, which was a drum machine, a hybrid drum machine, a software and a dedicated controller, yes, to do a drum machine. So I was involved in the software development of that. I did most of the software architecture and all the sequencing, pretty much everything about the audio DSP from the software. And then at that moment, I started also to manage the project, because this project was quite a bit long. I worked on that for maybe 4 to 6 years, because there was first a first hardware controller called Spark, and then we worked on a second smaller hardware controller called Spark LE. And the Spark software went up to version 2. So yes, it took me about 5-6 years working on that.
Wow.
At the end, I was also managing the whole project.
Mm-hmm.
So yeah, I grew up like this.
Yeah.
And then I started to work on the V Collection project. It was maybe some 8 years ago, mm-hmm. something like that, on the V Collection 4. And yeah, so I was both developing and managing the project. And then the company continued to grow, and the team I was managing continued to grow, and step by step, version after version. So yes, version 5, 6, 7. Today we are proudly releasing the 8th version of the V Collection.
Yeah.
So it's a long journey.
Yeah.
And
you must I was going to say you must have seen a lot of changes because you joined Arturia.
Yeah,
quite early on.
definitely. When I come at Arturia, we were about 15 people.
Wow.
And yeah, and now the company is about a bit more than 100 people.
Yeah, amazing.
Yeah.
And the one thing I was thinking about was how much the landscape of plugin and audio development has changed a lot over the past 20 years. You have a lot more independent developers. You have a lot more people who are releasing plugins. Probably early on, I imagine that you didn't have a whole lot of competition.
Yeah, that's true. Yeah. Yeah, at the beginning, we were among the first working on software instruments. There was not that much at that time. There was, of course, native instrument. Timur's know it a bit. And and there was Steinberg, Waves, of course. Yes.
GeForce.
Yeah, GeForce. Yeah, there was some history about GeForce and Arturia. I won't comment that because I wasn't there at that time. And yeah, and now yes, the landscape is much larger. But I think that's very good to have so many actors, so many competition, and it forces us to even reinvent and think about what we have to do and not falling asleep and just yes. So
yeah, one thing that we think about with companies that have been active for so long is working with these larger legacy code bases, and you don't have to deal with maybe with like a big DAW like Ableton does that has probably a code base that spans over 20 years. But in your products, I imagine that you have code bases that are quite old. And how do you handle that? How do you deal with that?
It's a nightmare, as you can imagine. We try to along the years to fix that by constantly removing some old code and replacing it with some new code. What we started, I think it was 5 years ago, maybe 6 years ago. We started to work on having all the same code base, at least for the what is not the audio engine, but everything else to have the same code base for all the software. Because at that time we were having maybe 3 different graphical frameworks at that time. For the Jupyter 8, the first version, we were starting working on Juice, but before we were working on VST GUI, and we also had some old code base on Carbon stuff for macOS and some specific Windows stuff on MFC, and it was a nightmare. So we decided to get rid from all of that and put everything on Juice, and we developed our own framework on top of Juice to have more flexibility, on the widget and things like that. So what we are using for Juice is mainly the component system for the graphical rendering and all the user events, keyboards, mouse handling, things like that. And yes, for everything else, we have developed our own custom widgets, and we also we started to not use it was also a long time ago, but starting to use more standard libraries code rather than Juice code, for instance, for the strings, the files, things like that. Thanks to modern C++, it's much more easier to have that. I know that in the meantime, Juice is becoming much more standard compliant on all the containers and things like that. Mm-hmm. But yeah, that's what we've done. It was a lot of work. It has been released on the V Collection 5. So at that time, it was much more comfortable to maintain and develop new products. But we still had legacy code for the DSP stuff. Mm-hmm. And that's why from now we are starting also to get rid of that, because it's most of this code have been written by people that are not anymore in the company. There is not that much documentation and things like that. So we have developed our own DSP framework, and all the new products are developed using this DSP framework. And for instance, we have released just today a new update of the Jupyter 8, which is completely rewritten from scratch on the DSP level code.
Wow, that's amazing. Yeah, I imagine when you're dealing with that older code base as well, that it must be tough to introduce new staff into your company, because they may be used to maybe working with Juice as a framework and used to the way that it's working, and then now they're coming into an environment where there's a lot of legacy code that may be working with a completely different paradigm that might not even have the same, might not even have great documentation for it. So there must be a big question of, how much time do you allocate towards updating the code versus working on new products? And
exactly, yeah, that's a big deal. And yes, we are at a step where we think now it's the time to get rid of this legacy code. So it will take lots of time, because we cannot do it for all the product at the same time, of course. So I think in the upcoming years, we'll continue to update maybe one or twice or two, maybe three if we are lucky, products per year, and continue to develop also new products, because that's you have all these user base, all the V Collection user that love these things and that want them to be upgraded, updated, and up to the standards of 2020, and not the standards of the 20s or the 2010s. But on the other hand, only putting the resources on updating existing stuff is not, it cannot work on a financial basis. Mm-hmm. So we have to balance that, of course.
Yeah. So you started as a software engineer, and then as time moved on, you moved more and more into management. And one question that I have was, how do you do any coding now, or are your responsibilities mainly management now? How do you miss coding?
Yeah, to be honest, no, I don't code anymore. I still can have a look at some code bases, and especially for the very old code base, which I am the one, even if I didn't work on this code base, since I'm the oldest guy in the software team, I know more than the other these code bases, because I worked on them, and and even today we've had, before the release, a new bug coming from on the modular V, and this is one of the instruments which has the oldest code base in the V collection.
Yeah.
And yes, we've looked at that, and we found a bug. I looked at it, and I helped the team to fix it, and it was just a fucking array overflow, and but because it was written using old C array things that are not, and it was not catched by our unit test and shit like that. And this was a bug that we knew it was here because we've seen it a couple of times in the last years, but it was very, very difficult to track it because we were not able to reproduce it on a on a regular basis. And for some reason, with the latest version, it was highly reproducible on a particular preset. And so we fixed it in a couple of hours. But that's also why we want to get rid of this old code base that is not easy at all to maintain. And yeah, so I'm not coding new feature, of course, and it's true that I'm missing it. But I'm also enjoying a lot the managing stuff. It's of course completely different. It's more human interaction with the team and trying to know the people very well and to fit their strengths with what is key for the company. That's really how I like to work, to make sure the people are really enjoying and liking what they are working on, and it's working well so far. Yeah.
And how big is your team?
The software team is about 12, 13 people. There is the DSP team, which is about, I think now 8 people. They have a dedicated manager, but I'm still managing the both team. So yeah, the software in itself is around 20 people.
Wow. One question that I have that I think about a lot, because I work with quite a few companies, helping them recruit for roles and things like that. And a lot of companies, they really only hire for kind of senior or very experienced developers. And there's this challenge where things seem to be very kind of top heavy in terms of the hiring. At Arturia, how do you handle bringing junior developers on board? What are some of the things that I guess my question is, how do you keep yourself from falling into a trap where you say, I only want the most experienced developers?
To be honest, at Arturia, we have a pretty young team. We hire a lot of people after their internship from school, and it works quite well. You have to balance it with more experienced developers, but we are not that much in the trap to trying to get the most experienced developer. We are giving their chance to the newcomers, and yes, as I was when I started at Arturia, and yeah, I think for instance in the software team, I think most of the people are between 20 and 30.
Yeah.
And we have a couple of very experienced guys, which are helping the younger to grow. But yeah, it's the more experienced people can also be a bit more difficult to manage and to it depends.
Because they're kind of set in their ways.
Yeah, exactly. Yeah.
Sure. How do you actually hire for your so you have somebody that is just coming out of university, maybe they know a little bit of Juice, maybe maybe they've done plugins. How do you spot a person that you feel is right for Arturia? What is it that you look for?
That's a good question. I think being passionate in music, and especially in computer music, is a very good point to be hired. But it's not required, and there are a lot of guys that were not at the beginning, knowing computer music and things like that, and that came to it with us. So it's I think it's a trade-off between that and being curious, open-minded, and of course very skilled in C++. I would say that's the first thing. You have to know your C++. And
when you say know your C++, what does that mean to you? What would you say is like the bottom level when you're hiring a junior developer and you say you need to know C++? What are some things that you would think about that?
It's maybe I went it a bit too fast. Maybe it's not your C++, but it's more how you reason about code and how you are also open-minded to discussion and feedback about your code. And if you are able to really understand easily what a code is doing, what is missing from it, and what could be the improvement on it, I would say that these are the most important skills I'm looking at.
So it's how you attack problems.
Yeah, exactly. Yeah, exactly. And it's not, it's not knowing all the different sorting algorithm or thing like that. This is not needed for us. At least on the software department. On the DSP side, they are much more demanding on the the hard skills, the mathematics and things like that. But on the software departments, we are more on the understanding of how a program works, how you can manage your memory, and what are the consequences when you have multi-threaded applications, things like that.
Yeah, because it's interesting to me because a lot of the things that you seem to mention seem to be things that are away from coding in a way, things like discussion and problem solving, and that. So it seems like the actual raw coding skills are part of the equation, but not the whole thing. So are there other things such as the persons, how they integrate into the team? How do you work with that? How do you kind of calculate?
Yeah, I think what I really think is important, and that's something I was thinking a lot for myself for what I learned from my university school. I felt when I arrived at Arturia that my school didn't give me that much, hard skills in computer programming and in how a computer works inside, things like that, compared to other people from other schools. But what my school gave me was the ability to learn and to learn quickly. And that's what I think is important. It's because if your brain is well connected, I would say, even if you do not know at the moment, how to code a lambda with this algorithm in C++ 11 or C++ 14, you can learn it, and that's for me the most important thing.
Yeah,
because your knowledge at the moment, at a given time, will be outdated in a couple of years, or even in 1 year, depending on what you are working on. So it's better that you know that you have to learn and that you will have to learn continuously during your career, and that's also better for you and for your wellness to continue to learn and to not fall in all the same thing and
random.
Yeah, very interesting. Now, shifting gears a bit. So, of course, Arturia. When I think Arturia, I think analog emulations of synthesizers. And one question that people ask about all the time is about analog modeling. How do you model something after an old piece of gear? I know that you probably, or you might not be able to really tell us like the inner workings of how you do that. I'm wondering if you could maybe give us a little peek into how you approach that.
I would say there is no magic. First, you need to get the unit. You need to, if you can, you need to get the schematics of the electronics. You need a very good knowledge in electronics engineering, and a very good knowledge also in discretizing things, and then it's if you have access to the schematics, you put these into equations, and then you run it. For instance, you start with Splice, LT-Spice, thing like that, software, and then you put it in code, and you compare, and you have to measure on the hardware, and you compare your result with the measurement you've made, and usually you are close, but not close enough to what you wanted to get, and then it's yes, we have we are lucky at Arturia because we have some very skilled people in electronic engineering for all the hardware synthesizer we are doing. So they are helping our DSP team a lot to better understanding what could be the problem in their modeling, because they are not taking into account, for instance, the ground coming in the electronics that could making some spikes in the
CPU.
Yeah, not in the CPU, in the frequencies, for instance, in 50 hertz frequency or thing like that. yeah, and then it's once you have a model you like, then you have to make some compromise in terms of CPU optimization and things like that, because the component level modeling is very, very CPU hungry, and if you want to have several voices of polyphony, you have to do some compromise. So you have to simplify the models where you think it can be simplified, and keep the very best modelization where you think it's very, very, very important.
Amazing.
Yeah.
And how much has computing power really helped with that, with the need for simplification? Yeah.
A lot. It's yeah, of course, it's a lot. But at some point we had I think it's in the early 2010s where the processors start to become more with several cores rather than increasing the frequency. It starts to be a problem for us, because we are always running on one CPU thread, and so the processing, the increase in processing power were not that much helping for us. But it's still very good. I mean, even even if the processor are not getting higher CPU frequency, it's still crazy the amount of computation you can do with CPU nowadays. It's
yeah.
Can I ask a quick question, Josh?
Yeah,
of course.
I'm just wondering, are you saying then that you don't do threading inside of the audio thread? You don't use multiple threads when you the audio?
At Arturia, not that much. A bit. It depends on not in all instrument, and we are working on that to make it possible in every instrument. But at the moment, it's not. Yeah. It's a bit complicated also, because if all the we are working, our software are run in DAW, and it can also conflict if several software are using multiple cores at the same time. So it's a trade-off, I would say. But I think this is still the way to go, given the new computer coming from the for instance, Apple with the new M1 and things like that. But yeah, I still don't think it's a good way to go to have all the VST plugin manufacturer making multi-core processing without knowing what are doing the other plugins.
Yeah.
Yeah, and I remember, I think it was maybe in 2010 or something like that, when Steinberg was presenting VST3 at Music Messe, and there was these guys from UI, which were asking why they didn't had multi-thread processing in the VST3 SDK. And at that time, I was already thinking it was a very good idea, and I still don't understand why there is no move in that way in the plugin development. But if we start to talk about plugin format and things like that, I think we can talk about the whole night on that topic. So
amazing. So one thing that I thought about was about how Arturia is so known for analog vintage synthesizers, but then you came out a couple of years ago with Pigments, which isn't, which is a whole new type of synthesizer. One question that I had was, how do you, when you're creating something that isn't modeling analog gear, how do you make a synth unique? How do you make it sound unique? Because people start off with your typical waveforms, sine wave and saw wave, square wave. What are some things that you do to try to get a unique sound out of a synthesizer?
That's a very good question. I think with Pigment we started on a blank page, so it was a very good opportunity, but it was also very scary because you can do whatever you want. And I think what makes Pigments unique is it's not that much in the sound. It's more all the integration of what we try to make the workflow of the software very easy to grasp, and also it's the combination of the different feature, what you can modulate and what you cannot, and what you can access directly from a knob or with more clicks and things like that. I think it really defines how the instrument will sound also at the end. What feature you decided to add and what feature you decided to not add, and I think that's very hit for Pigments. So yeah, for sure, when we started to work on that project, we wanted to make our very own synths, but yeah, it was not that much we didn't want to make it have a particular sound. We wanted to make it as versatile as possible also.
I see.
Yeah.
Wow. And one of the things that struck me about it was the graphics aspect of it. Was that with OpenGL or?
Yeah, it's not it's a combination of OpenGL rendering and standard JUICE rendering.
Yeah. Nice.
Yeah.
That's great. And as you were saying before, you have a new release today. Can you tell us a little bit about your?
Yeah. So we released the version 8 of V Collection. So it contains lots of new software. So there is a vocoder. So this one is very particular for us because this is our first instrument where there is a mic input where people can really sing in, and very, very, very particular. And it's very, very funny because you can also put your own sample in it, so you can play it just like a synth. So if you want it, there is an emulator too. So this one is very funny, and the characteristic is very on the factory library, which replicating the famous sound of the emulators, and but there are some very, very nice feature in it. It's surprisingly very powerful, despite the original instrument was not that. It was one of the first samplers at that time, but yeah, compared to other synths from the same era, the sonic palettes, yes, it's mainly on the possibility to sample, and so you have some sounds that are not less synthetic, I would say. Then there is an emulation of Juno called the June 6V. So this one is, we wanted to have a synth that is less intimidating and easier to start with, when you do not know that much in synthesis. So this one is very oriented to that, because it does not have that much parameters and feature, and it's still very powerful, and the sound is very fat. And then we have, yes, the OBXA, which was previously released but was not included in the V collection. We have a very big update, as I told you, on the Jup 8V, which we completely rewrote the DSP code from scratch. So it's, yeah, I really engage people who knew the first one to compare, and you see that, yeah, the state of the art in DSP modeling has changed compared to what was possible in 2007, the date of the first release of the Jupyter 8V. Amazing. And there is, sorry.
No, go ahead, please.
Yeah, well, there is there is an update of the stage 73. So we've updated the physical modeling engine, so it's much better. We have a very big update on Analog Lab V, which Analog Lab is the combination of all the presets and the audio engine of the whole V collection. So in it, you can have access to all the sounds from the V collection. And we completely redesigned the interface and the workflow. So again, I invite everybody to try it. It's very nice to use when you are just looking for sound and not that much into creating your own presets and sound design. It's very nice. And yes, we also completely redesigned the sound browser for all the existing instruments. And we've added a new dedicated side panel with some features like in-app tutorial, so you can learn how to play with the instrument and how to sound design with it for all the instruments.
Wow. That sounds like a huge project.
Yeah, it's crazy. I think this was one of the biggest one we did since I'm managing the project. So yeah, as I told you, I'm managing the V collection since version 4. So it's yeah, I would say maybe between 6 to 8 years. So yeah, and on that one, yeah, internally, it's I would say it's around 30 people working on it, and with all the external sound designers and things like that, I think it's more than 50 people working on the project. And on the last year, yeah, it's we are very proud and happy to finally make it public. And yeah.
Yeah, congratulations. How long does that? I'm curious how long that cycle takes. If you could tell us, like, where do you start? Where you say, okay, we're going to do this. I mean, are we talking a year, 2 years?
It's we are on a cycle. On the V collection, we are on a cycle to every 18 months we release a big update of the V collection. So once V collection 7 was released 18 months ago, we started to work on the V collection 8. But first, it's looking for and defining what would be the next instrument. So it's always complicated. We need to find what would be interesting. and to discuss this, what is feasible, what are the team available or not, what are the skills required. And then once we know that, it takes between, I would say, between 6 to 8 months. And then we start the project. First, we start with the modeling, of course.
Were you going to say something else?
Yeah, and this takes, it really depends, but it takes up to 1 year to model the instrument.
Yeah.
And once we start to have a good model, we start to also to work on the software. Thanks to our internal framework, it's now easier and easier to make prototypes and so to test what is doing the DSP we've put in it, and we put into our QA department to do some testing during the development. And then once we think we are good in terms of modeling, we start to work on the presets. It's always a tricky part because if you start too early, you can find issues that can change the sound of the preset. So it will require the sound designer to redo the preset. But if you start it too late, you won't have enough time to do the proper sound design. So it's always complicated.
Wow. And
when you have 4 instruments in parallel, plus a complete redesign of the, for instance, on the browser, the preset browser, we have changed the preset types and styles and how the tags are managed. So we had to retag and all the existing presets. So it's
it's a big project.
It's lots of things to manage in parallel.
Great. I have one more question, and then I think we could turn it over to the audience for their questions.
Yeah.
Where do you feel that plugin development is going? So, of course, you see that with Apple, there seems to be this move towards taking the mobile ecosystem and maybe merging it or mixing it with the desktop. What we're doing on the desktop. Where do you see plugin development heading in the future in terms of what do you see?
That's a good question. On the mobile thing, it's very complicated, because there are the tech companies who want to go somewhere, but there is also the market and the people, and we cannot force people to go wherever we want to. And the mobile platform are here for maybe, I don't know, but it's almost 10 years now that we have the iPad and things like that. And at the beginning, we all thought it was the future, but now 10 years after, it's a bit there, but it's not where the majority of the market is. So where it will come, that's a good question. It's I think it's a very mature market, the plugin, and I really would like to see some breaking new technology that make things change, but it's very difficult to make this kind of move. Take for instance the MIDI. The MIDI is here for 40 years now, and we now have the MIDI 2.0 coming finally. How much time will take the manufacturer to really embrace it? And that's a good question. I don't know.
Yeah.
But I really would like, because we are all fighting with all this retro compatibility. For instance, VST2 is, we are still forced to support it because of some companies, some important companies are still on it. It's changing. Maybe in a couple of years we'll be able to remove VST2 support, but it's not yet there. So I won't be too much, I won't do some hypotheses that things will change a lot in the coming years. I see more in the hardware and software integration, and maybe some some product that are more hybrid and let the user play with or without the computer, thing like that. Because it's now easier and easier to have embedded platform that can run software that were designed for the computer.
Yeah.
You can look at your Akai with the Force and the APC, now Native Instruments with the Machine Plus. I think this is more what things will come in the future.
Yeah. I do have one more question before we move to audience questions. What are your thoughts on, of course, there are new audio development technologies like Soul and other languages that are trying to lower the barrier for audio programming, and what do you think it would take in order for a company like Arturia to really take a serious look at these other languages, these other workflows, and say, okay, this could save us a lot of time, a lot of heartache with C++, or do you feel that you're stuck, or do you feel that you're kind of married to C++ now?
Yeah, it's a bit like the assembly, then the C, then the C++, and now our embedded guys are starting to get more and more into C++. I don't think there is any more people at Arturia doing C. But going to even more modern languages like yes, the Soul is very, very interested. But when it came up, I thought, if a very, very big company, like Apple or Google or Microsoft is supporting it, and it's available in their platform, I thought it would be more adopted, like the CUDA, for instance, in the graphic platform. But for smaller company, like even the bigger company in the music industry, we are still in a niche market, and it's very, very difficult for a new language to come and to be a de facto standard. So
yeah. Do you think it's because of the knowledge base of your existing software team, or do you think that it would just be the time that it would take to adopt it, or do you think that there are things that are missing from the language that you would need to see?
I think it's more on, especially for things toward embedded platform, it's more on the industrial and the risk that the long-term maintainability of the thing.
What about Rust? What are your thoughts on Rust?
I really would like to have my team working on Rust. I think it's technically speaking, it's great. And I will try to push my team to work on it, but it's very difficult to make the jump. Once you know your tools, I think it's related to what I told you about learning things. For the people, for the single people, it's very interesting to learn these new languages and things like that. But for a company, it's a much more difficult step to change these kind of things.
Yeah. Great. I think we're ready to move to audience questions. Thank you very much, Kevin.
Thank you.
Yeah, thank you, Kevin. Yeah, we do have a few audience questions. I would say quite a few of them are kind of about something that you discussed earlier, like kind of getting a job, hiring, this kind of stuff. So maybe I'll just ask those first. So the Samax80 is asking how to get experience to get a job in audio programming. I think this is an interesting question, because you said earlier you were actually hiring a lot of people who just come out of school.
Yeah.
But or maybe you have like relatively junior people. But I'm actually wondering this as well. Like, what would you tell someone? How would they even acquire the skills to get a job like that? Like, what would you recommend?
I would say first, it's if you are passionate with that, I think Juice is a very, very good framework for that, because you can learn a lot of things with it, and from all the aspects of audio plugin development. I mean, you have the DSP, you have all the graphic managing things, and you have all the problems, related to multi-threaded and things like that. So I think I would say start to work with Juice. It's the best thing to start with, and then look at the resources. If you like to make this kind of things, look at the resources on the internet, like the musicdsp.org, and try to really take the end on it, and then make your own projects. I think when you receive a resume, if you see that you have a girl or a guy that is doing some open source project, even if it's not a big things, but just some small things, it's always better to sell you to the recruiter, I would say.
Mm-hmm.
All right. Yeah. Thanks. I think that's really good advice. There's a couple other questions around this kind of area. So John Rupsch is asking, I know your role is in software development, and I'm really interested in DSP jobs. Is there someone at Arturia that would be best to ask questions about DSP-specific roles?
Yeah, definitely. If you want to, I won't be able to give you on public his email address, but if you drop me a message, or maybe we can find a way to. I think we'll be happy to give you some insight on it, definitely. And it's kind of funny. I remember maybe 5 or 6 years ago, I received an email of a young guy, a young student. I didn't even know how he got my email address, but he asked me just that question: what should I learn to come to work at Arturia? And I answered him. So I gave him pretty much the same advices I told you. And so he did that, and a couple, and I also gave him a couple of universities and schools that I know are good for learning that. And a couple of years after that, he applied as an intern at Arturia, and he get hired, and at the end he finished being hired at the company.
Wow, great. So you're saying that a lot of it is about determination.
Definitely is that.
Yeah, that's what I've seen. Now we know thousands of audio developers, and it seems that right away I can tell the ones that are going to get hired, that are going to be successful in the career field, just from the sheer determination and the work ethic, and like you were saying, the curiosity. I think people underestimate that so much.
Yeah, I think also that this is kind of more important than like experience, right? You can have never worked on like a piece of real audio software before, but if you know how to program, if you have like an understanding of like roughly how stuff work, you can like dig in and figure it out.
Yeah, just try it. Just try it.
Yeah,
try it, and you will have a lot of fun. I mean, it's crazy when you start to do audio programming and you have your first piece of code working. It's such a pleasure to get this, and I mean, I think we are all the same. When we see young people passionate, and we all want to help them, and giving them advices, and so yes, the advice I would tell them is just don't hesitate to contact us, and I think you can find me on the internet somewhere in different forums and things like that. And if you ask me directly, I will answer you and give you advices. So, and I don't think I'm alone on that. There are lots of people like me in this industry.
Yeah.
Right. So very related to that, Jackson Abel asking whether you currently have internships in engineering.
Yes, it's in. We have done, because there is some kind of season in internships, and so it will start in early next year. We have done pretty much all our recruitment for the period of February to the summer. But again, if you are motivated and interested, don't hesitate to drop an email at jobs@arturia.com, and we'll still look at it. And even if it's not that year, maybe it will be next year.
Yeah.
So there is a question by Eldit Bernard asking, what is actually your educational background?
My educational background. So yes, as I said, I went to university in. So I started with. I graduated in computer science, and then I went in master's again in the university. Master's degree in Bordeaux, University of Bordeaux. There is a specialty in audio and image processing. But again, it was so I have a very generic background, and the audio and image processing was only in the very last year of my student. So
yeah. All right. Yeah, we have a few more questions. So Michael Kaufman is asking, actually somewhat related to the educational topic. So at university, we learn a lot about software development process, analysis, design, etc. But in real life, how do you do this at Arturia? And I've heard that people, for example, rarely use UML these days.
So
I guess the question would be how far removed is what you learn at university about like building software from what's actually going on at a place like Arturia?
Yeah, it's true. It's true that we are not using UML as much as what we should, I would say. But I think it's good to learn that, because it helps you to reason about a program and to think about what are the what are the aim of each individual part of your program, and to not couple that much the things, and to really the separation of concern thing and all that. I think that's why it's important to learn that, even if it's true that when you are at your day-to-day job, you are not that much doing UML, even if it's still very, very important to try to document as much as possible what you're doing.
Yeah.
All right, thank you. So John Day is asking, can AI be a tool to emulate analog sounds? So I'm shifting gears a bit. We have a couple questions about analog modeling and analog sounds. What do you think about AI in that context?
It can definitely help. At the moment at Arturia, we do not have running code in the software that are using AI to model stuff. But we have some tools, some in-house tools that using AI to help us model stuff. And I think in the upcoming years, it will continue to be more and more used.
Wow.
In all the aspects, even not only modeling, electronic modeling.
Cool. So that's really interesting. Looking forward to that, becoming more widespread, because I think it's a technology that a lot of people kind of have maybe heard of, but I think in traditional plugin development isn't necessarily mainstream yet. But they're definitely really looking forward to that.
Yeah, but there are more and more companies using it and marketing it, and very important company like Isotope or even recently, Native Instruments had this AI stuff on the guitar rig. So, and it's. I know that there are more and more people, more and more research field. If you look at the DiFix stuff, there are more and more papers related to that. AESM. So,
yeah,
it will continue to grow, and I think you were asking what will come in the future. I think definitely this is coming, and this will continue to grow in the coming years.
All right. So final question from the YouTube chat is by George Conturas. And it's a bit of a more general question about analog modeling. Can you expand on the state of the art for analog modeling in 2020?
To be honest, I'm not the best person to talk about that. But again, if you want to have some ideas on the state of the art, look at the academic papers coming from the DFX, from the well-known universities like Aalto University, like some very good also in UK, in Italy. And
you got Queen Mary in London, Goldsmiths in London, Urcam, of course. So quite a few resources.
Yeah. Right. So then I don't think we have any more questions at the moment. So thank you again so much, Kevin, for patiently answering all these questions. I definitely learned a lot.
You're welcome. Thank you again for inviting me. And that was the first time for me, and very, very interesting. And very cool.
Thank you very much for your time, and Chris as well for your time with that amazing IDE. I mean, absolutely phenomenal. This is fantastic meetup, and once again, thank you to our sponsors, Juice, Sonox, and Focusrite for their support and for helping to make the audio Programmer Meetup possible. And we'll be back next Tuesday, so it's the second Tuesday of the month. I don't have the date right in front of me.
The 12th of January.
The 12th of January. Fantastic. I believe we are still looking for some speakers for that next meetup. And one of the most important things is that you don't have to have the most experience to actually present at the meetup. Even if you have one of your first real projects that you would like to show us and share with the audio programmer community, we'd love to see it. And it's a great way, of course, to show people your skill set and show people what you're up to. You can actually submit a proposal over at theaudioprogrammer.com /submit. Also, be sure to join our audio programmer community on theaudioprogrammer.com /community. And yeah, is there anything else that we need to mention? Yeah, this is the last one for before the holidays. So
yeah, we wish everyone a Merry Christmas and a Happy New Year. And I hope to see you again in 2021.
Yeah.
And yeah, it's been obviously a challenging year for many of us, obviously because of what's going on in the world right now. But I think I'm actually really hopeful that next year is going to be better. And yeah, really looking forward to carry on with this meetup and have exciting new talks and Q&A sessions and meet exciting new people here. So yeah, I think it's going to be awesome. So thank you again so much for joining us. Especially to those of you who tune in every month. I saw on the YouTube chat, that some names, they just keep repeating. So people are actually coming back. So I'm super excited about that. I'm just thank you so much for listening to what you have to say and to our guests. And it's really huge pleasure and huge honor every month. So
yeah, it's definitely a huge honor. And we wish everybody a safe holiday season. And we, of course, will be continuing even through the holidays to be talking about all things audio programming on the Discord and do tutorials. So be sure to keep up with us. And yes, we will. With that, we'll sign off. And thank you. And see you next time.
Happy New Year. See you
Thank
next
you,
time.
guys.
Bye.
Bye.
Bye-bye.